All right, this next part of the lesson tonight is going to be over the topic of power, which can be located in the mechanical energy module. Power is the amount of work divided by the time. I don't know why it says don't right there. The amount of work divided by time. So we can see here that the formula for power equals work divided by the time. Power is also the rate of energy transfer, or how fast work is done. The unit for power can be joule per second, which is also known as a watt. Power can also be defined with velocity, and we need to know this for formulas. So we have P equals work divided by time, or Fx divided by time equals the velocity. In this case, we would be limited to a constant force applied as a constant velocity. This is going to make sense when we start talking about those practice problems. Another thing, especially very popular in the United States, is that it can be measured by horsepower, which is usually measured in watts, but can also be used in horsepower as well. So remember, you might need to know the conversion factor, that 1 horsepower is equal to 746 watts. And let's talk a little bit about excuse me, the power company. So where you actually get your power that goes into your home or your electricity. So remember that power companies do not sell power. The unit for electric energy purchase is actually kilowatt per hour. This is an energy unit. So if you go ask your parents to look at one of your power bills or electric bills, you should see this unit, kilowatt per hour, and that's how they are being purchased and measured. All right, now we're just going to go ahead, it was a quick lesson, and jump into the practice problems. So we have a 10 kilogram box accelerates from 4 meters per second to 11.5 meters per second in 9.75 seconds. The first question is how much work is done on the box. So the first thing we need to do is figure out what formulas to use. So we have, the cursor, there it is, work equals 1/2 mass times velocity squared minus 1/2 mass times the initial velocity squared. We plug in what we know, 1/2 times 10, which is the mass given to us in the problem up here, times 11.5, which is that final velocity squared, and then minus 1/2 of the mass, same thing, 10, times that initial velocity, which would be 4, again it's given to us in the problem, squared. We plug that into the calculator and we should get 581 joules. The second question asks how much power is generated moving the box. So again, your power formula is power equals work divided by time. So the work that we just saw in the previous part of this problem was 581 joules divided by the time, which is given to us up in the problem at 9.75 seconds. Plug that into the calculator and we should get 59.6 watts as our final answer. Here's practice problem number 2. A 20.0 horsepower motor lifts a 175 kilogram crate at a constant velocity from a dock to the deck of a ship. What must be the force on the crate for the travel at a constant velocity? So remember, the force up must equal the weight down. So force equals mass times gravity. So we have 175, which is given to us in the problem, which is the mass times the gravity, which is the gravity constant of 9.8. And we should get 1,720 newtons. Second part of this problem says how many watts is the power output for the motor. So we have the motor of 20.0 horsepower. Now we're going to convert it into watts. So remember the conversion was 746 watts per 1 horsepower. So we plug that into the calculator as a conversion, and we should get 14,900 watts. The last part of this question states, what is the velocity of the crate as it's being lifted? So we have the formula that we talked about with the velocity in it. We plug in what we know. We just calculated 14,900 divided by the force that we calculated in the first part of this problem, which was 1,720, and we should get 8.66 meters per second. And that is it for the power lesson. Let me know if you have any questions.